Hi class, this video is on the properties of logarithms, so let's get started. Okay, so we have a couple of properties of logarithms. One of them is the log base b of m times n is equal to the log base b of m plus the log base b of n. Okay, now logarithms basically extract the exponents, and it's basically because if we have, say, x or b to the m times b to the n, we get b to the m plus n. That's basically why we're adding exponents there when we multiply numbers. But we'll actually even prove that and show that. So that's property number one. Property number two is the log base b of m divided by n is equal to the log base b of m minus log base b of n. And again, that's because if we have b to the m divided by b to the n, that's equal to b to the m minus n, the exponents. And finally, 3, we have the log base b of n to the t, then that's equal to t times log base b of n. And that's basically if n is equal to b to the if n is equal to b to the a, say, then n to the t is equal to b times a to the t, which is equal to, I multiply those b a times t, and I'm multiplying exponents here versus subtracting or adding. And that's basically why that is. But let's prove one. Okay, the first one was log base b of m times n is equal to log base b of m plus log base b of n. So actually prove it. It's kind of cool. Prove it, or proof. Okay, so we let let's let log base b of m be equal to some number, say number 1, and also let log base b of n be equal to some number 2, right? So what does this mean? Well, that means that means we're taking the b exponent out of m and getting number 1, so m was equal to b to the number 1, right? That's what it means. That's what a logarithm is. We extract the b exponent from the number, so m is equal to b to that number. Likewise, if the log base b of n is equal to some number 2, that meant n was equal to b to that number. Okay, so let's take a look at log base b of m times n. So log base b of m times n is equal to, well, log base b, well, m is equal to, right, b to the number 1 times b to the number 2, right, which is equal to log base b of b to the, we add these two, that's just number 1 plus number 2. Okay. And so, well, log base b of b to this number is just equal to that number. We're taking the b exponent out of b to the number 1 plus number 2, so that's clearly equal to just number 1 plus number 2. But what are these numbers? That's log base, this number 1 is log base b of m, and this number 2 is log base b of n, so that's equal to log base b of m plus log base b of n. Okay, so it really does just come from that we add exponents. And the other two are proved just the same way, or very similarly, so we won't quite bother doing those. But we'll do some examples now. And basically, you can either expand logarithms, and of course log base 10 is just equal to log, and all these work for log base b, so I'm just going to use log base 10 and use logs. So the log of, say, the square root of x times y cubed all over z to the 4th can be expanded. That's going to be equal to, if we use our rules, that's going to be equal to the log of square root of x. That would have been times, it's times this, so it's then we can add the log of, well, when we multiply, we just add them, so that's log y cubed. And when we subtract out what we're dividing by, so minus the log of z to the 4th. And then we can use the second rule, the third rule. Write it again. The third rule was log of x to the t was equal to t times log of x. So we can expand these by saying, well, that is also equal to, well, the log of square root of x, the square root of x is also equal to x to the 1/2. So we can bring that 1/2 in front. 1/2 times log of x plus, now the 3 we can bring down just like this, plus 3 log of y, and then minus, we can bring the 4 down in front, 4 log of z. So that's expanding one log into this. And contracting, we can take this and bring it into that. But let's do another example. Okay. If we have the log of the cubed root of x times parentheses x minus 1 to the 4th, if we have this logarithm, then we can expand that to log of x to the 1/3, because that's what the cubed root of x is, and then plus that multiplication, log of x minus 1 to the 4th. And then we can drop those down in front. 1/3 log of x plus, we can bring the 4 in front, 4 log of x minus 1. Okay, so that's expanding. We can expand it to this one. And now we can also contract them. Say if we had 2 log of y plus 3 log of x minus 4 log of z. Well, what is that equal to? Well, we can bring those up here. That's equal to the log of y squared plus the log of x cubed minus the log of z to the 4th. using that other rule using the property 3 in the opposite direction. Now we can do the addition here. That's equal to log of y squared times x cubed minus a log of z to the 4th, and the minus will bring it down. So contracting that to one logarithm, that's going to be the log of y squared x cubed divided by z to the 4th. Alrighty. For our final example, okay, we can contract this log of 2x plus 5 minus a log of x. If we wanted to write that into one logarithm, well, we just use the one rule. That's equal to log of 2x plus 5 divided by x. So that's equal to that one. So that's contraction. Okay, well, I hope you found this video useful and helpful to your learning and that you enjoyed it. Cheers.